in this part of the problem, we want to determine whether the following limit exists, and if they do not exist, we justify why, and if they exist, we find the actual limit. Okay, so here, remember, when we just plug in, right, for the limit as x to 0 of arc sine x divided by 2x, when you just plug in 0, you find something like 0 divided by 0, right? But this is indeterminate, right? So what we are going to use, L'Hopital's rule. So L'Hopital's rule says, if you have a situation of 0 divided by 0, or say infinity divided by infinity, you can take the derivative of the numerator fraction and the derivative of the numerator denominator, and then simplify, right? So let us go ahead. This will be the limit as x goes to 0 of what? So the derivative of arc sine from the integral table, the derivative table, is 1 divided by the square root of 1 minus x squared, right? Then the derivative of 2x is just 2. Okay, so you can see here, as x goes to 0, this becomes 0 here, right? So you just have something like 1 divided by the square root of 1, right? Then everybody divided by 2. Okay, and 1 divided by the square root of 1 is just 1, right? So this is just 1 divided by 2. So this expression that looks like it's indeterminate, its limit is 1/2.